are prime numbers. For example, when we're talking about just finding factors, you want to find two numbers that multiply together to get the designated number. So for 18, I have the factors of 1 and 18, 2, 9, 3, and 6. But in prime factorization, we want to make this 18 only have prime numbers. So I'm going to use the numbers 2 times 9. 2 times 9 multiplied together gets 18. Now I'm going to look. Do I have any prime numbers? Remember, a prime number only has two factors, 1 and itself. 2. 2 is the only even prime number we have, so I'm going to circle it so that I know I have a prime number. 9. I know that 3 times 3 equals 9. So 9 was not a prime. Now I'm going to look at 3. The only two numbers I can multiply together to get 3 are 1 times 3. So I can circle them. So the prime factorization of 18 is 2 times 3 times 3. Let's try another one. This time I'm going to use the number 24. Now remember, you want to find two numbers that multiply together get 24. So I know that 4 times 6 equals 24. And again, I'm going to ask myself, is 4 a prime number? Well, I know that 1 times 4 makes 4, but also 2 times 2 makes 4. Let's look at 6. I know that 6 is not a prime number, so I'm going to figure out what two numbers can I multiply together to get 6. I can do 3 times 2. Now I know that 2 is the only even prime number that there is, and that 3 only has the factors of 1 times 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. I like marking off when I have multiples of one number so that I know I don't put too many down. Now, you may wonder, what happens if I use two other factors of 24? Let's say I use 3 times 8. Now I already know that 3 is a prime number, so I can circle it and I'm done with that part. But 8 can be made by 4 times 2. And again, I know 2 is my only even prime number. And I know that 4 can be reduced to 2 times 2. So my prime factorization for 24 is still 2 times 2 times 2 times 3. No matter what factors you use for 24, you'll always get the same prime factorization. Now, the reason we can't use 1 times 24 is that 1 is not a prime number, and it is not a composite number. It's a special number, because the only number used to make 1, the only factor that 1 has is 1. So it is the only number that only has one factor. So it's not prime or composite. Let's try another one. Let's look at 30. What can I multiply together to get 30? Well, I know it ends in a 0, so I know I can either use a 5 or a 10 to get it, so I'm going to use 10. 3 times 10 equals 30. Now again, you want to look for the prime number. We know that 3 is a prime number. The only factors it has are 1 and itself. Now I'm going to look at 10. I know that 2 times 5 equals 10. I'm going to circle my 2 because it's a prime number. I'm going to circle my 5 because it's a prime number. So the prime factorization of 30 is 5 times 3 times 2. Now, If you can't remember your prime numbers, I would take out my hundreds chart with the sieve of Eratosthenes. That's going to be the easiest way to figure out which numbers are prime. If you don't remember it, I'm going to link in my description below a video that has to do with the sieve of Eratosthenes just to refresh yourself. Also, if you're having a hard time with the factors, you should either create a multiplication grid, print one out, and you can use it. Let's do one more. Let's do 45. What two numbers can I multiply together to get 45? Well, I know I can do 9 times 5. And if you have your chart, or if you looked at the video, you know that 5 is a prime number. The only factors are 1 times 5. 9 can be reduced to 3 times 3. And those are also prime numbers. So I know that the prime factorization of 45 is 3 times 3 times 5. Again, I'm linking that other video on the bottom, and if you need to rewind to look through it again, feel free to do so. And I hope that if you have any further questions, you'll come up to me at the end of class. Bye.